Science for Pigeons, Earth and the Atmosphere. The structure of Earth. The Earth has a layered structure. This structure resembles a sphere. It consists of a crust, a mantle, and a core. The crust is a thin outer layer. This layer is solid rock. Life, like you and I, exists on the crust. Below lies the mantle. The mantle is mostly solid, but its deep material flows slowly. Flow occurs due to increasing temperature. Temperature increases with depth. The core sits at the center. The core is iron and nickel. The crust contains minerals. Minerals are elements and compounds. These minerals form rocks. Silicon and oxygen are elements. They form the compound silicon dioxide. Silicon dioxide forms quartz. Quartz is a mineral, and granite is a rock. The Earth's surface comprises tectonic plates. The crust and upper mantle are cracked. These cracks create large pieces. These pieces are tectonic plates. Plates float on the mantle. They move constantly. Their movement is very slow indeed. Movements measures centimeters per year. Mere centimeters. Plate edges meet at boundaries. The African plate moves toward the Eurasian plate. Sudden movement causes earthquakes. Earthquakes occur at plate boundaries. Volcanoes also occur there. Types of rock. There are three main types of rock. First, are igneous rocks. These form from magma. Magma is molten rock underground. It rises through the crust. It erupts as lava. The rocks contain various minerals. These minerals form interlocking crystals. The crystals are randomly arranged. Crystal size defines texture. Size depends on cooling speed. Slow cooling creates large crystals. There are two igneous types, intrusive and extrusive. Granite is intrusive. Basalt is extrusive. Extrusive rocks cool quickly above ground. Intrusive rocks cool slowly underground. They are later exposed by erosion. Second are sedimentary rocks. These form from layers of sediment. Sediment is rock fragments or dead matter. Layers settle in lakes or seas. This occurs over millions of years. They also form from evaporation. Evaporating water leaves solids like salt. Minerals cement the layers together. Fossils form within these sediments. Fossils are remains of dead plants and animals. Specific fossils indicate relative rock age. Examples are limestone, chalk, and sandstone. Third are the metamorphic rocks. These form from heat and pressure. Heat and pressure act on existing rocks. This process occurs over long periods of time. The rocks may contain tiny crystals. Some rocks show layered structures. Examples include marble, slate, and schist. The rock cycle. The rock cycle changes rocks. The cycle operates inside and outside Earth. It requires millions of years. The cycle transforms three rock types. These types are igneous, sedimentary, and metamorphic. Rocks change from one type to another. The cycle has several stages. First is weathering. Weathering breaks rocks into smaller pieces. Onion skin weathering is one method. Here, daytime heat expands a rock's surface, nighttime cooling contracts it. This repeated expansion and contraction breaks the surface away. Freeze-thaw weathering is another method. Water enters rock cracks, freezing water expands. This expansion widens the crack. Repeated freezing and thawing breaks pieces off. Next comes erosion. Erosion wears rocks down. Rain is a common way this happens. Then transportation moves the eroded material. Wind and water transport material globally, of course. Then deposition lays down this sediment. Burial comes after. Compression and cementation squeeze the layers. These processes form sedimentary rocks. Heat or pressure then acts. This further squashing and heating creates metamorphic rock. Then melting occurs. Intense heat partially melts the rock. This melting produces magma. Cooling solidifies the molten rock. Solidification forms igneous rock. Finally, exposure returns rock to the surface. Exposure leads back to weathering and erosion. The surface rock mass remains constant. Weathering removes material, but new material replaces it. Recycling. The Earth provides all resources. Resources such as metal ores. Resources such as fossil fuels. Fossil fuels are coal, crude oil, and natural gas, solid liquid gas. Crude oil also provides plastics. These resources are limited, of course. Extraction depletes them, makes them run out, and recycling addresses this depletion. Recycling uses old materials for new products. This process conserves limited resources. It also seems to use less energy. Energy often comes from burning fossil fuels. Less energy means lower cost. Furthermore, recycling reduces landfill waste. Consider recycling aluminium cans or aluminum cans. Without recycling, new ore must be mined. Mining consumes money and energy. It damages landscapes. Transporting ore requires even more energy, and extraction requires even more energy beyond that. Disposal in landfill also has its own costs. Recycling just 1 kilogram of aluminium cans saves 95% of the energy. It also saves 4 kilograms of aluminium ore, preventing significant waste. Recycling is generally more efficient, although disputation is coming out about that now. Efficiency does vary by material. Aluminium recycling saves 95% energy. Plastic recycling supposedly saves about 70%, and steel recycling 60%. The carbon cycle. Carbon is without a doubt fundamental to life. The carbon cycle moves this element around the Earth. Photosynthesis removes atmospheric carbon dioxide, the carbon dioxide in the atmosphere. Plants and algae also absorb this gas. They use its carbon. This carbon builds carbohydrates as well as fats and proteins. Feeding transfers carbon along the food chain. Animals consume plants, animals acquire the carbon, and then they use this carbon. Makes sense? They build their own fats and proteins, and then predation, which is predators eating prey, continues this transfer. Respiration returns carbon dioxide to the atmosphere. Plants respire, animals respire. This process releases the gas. Then death introduces decomposers. Bacteria and fungi consume dead matter. They also consume waste. Decomposers respire. Their respiration releases carbon dioxide. Some remains avoid decomposition. These remains bury very, very deeply. They form fossil fuels over time. Combustion burns these fuels. Burning is combustion. Combustion releases stored carbon dioxide, and so the carbon cycle is more or less complete. The atmosphere and the climate. The atmosphere surrounds planets. The atmosphere of Earth contains gases, of course, the air we breathe. 4/5 is nitrogen, or 78%, more precisely. 1/5 is oxygen, or 21%, more precisely. But 0.04% is carbon dioxide, and trace amounts of other gases. Water vapor and noble gases exist in very small amounts. Water vapor is more abundant than carbon dioxide, naturally. Carbon dioxide levels are increasing, and human activity is contributing to this increase. Natural causes also contribute. Burning fossil fuels releases carbon dioxide. This powers cars and generates electricity. Deforestation removes trees, but the trees being gone, that means lower levels of photosynthesis. Less photosynthesis removes less carbon dioxide, putting us in trouble. Carbon dioxide is a greenhouse gas. Greenhouse gases trap Earth's heat. This energy warms up the atmosphere. This process resembles a greenhouse. Glass traps heat inside in a greenhouse. Carbon dioxide levels are rising. Other greenhouse gases are also increasing. Global temperature shows a long-term increase. Most scientists link this to the rise in carbon dioxide. This temperature increase is called global warming, a type of climate change. Climate change has very serious effects. Glaciers and ice sheets are melting, for example. Melting occurs in Greenland and in Antarctica. Faster melting raises sea levels. Higher sea levels flood coastal areas. Also, rainfall patterns are changing. These changed patterns challenge our agricultural systems. Farmers don't really know what to do about that. Crops become harder to grow. It becomes harder to feed ourselves.